Hi, welcome everybody. Today we will be talking about the Oracle Cloud Infrastructure Data Science Service. My name is Elena Sunshine, and I am a Senior Principal Product Manager on the Data Science Service. During the presentation, you can add your questions to the chat bar, and we will be answering them at the end during a live Q&A session. Also, at the conclusion of the presentation, you will see links to helpful resources along with a survey for which we would appreciate your participation and feedback. Let's get started. Whether we realize it or not, we've all probably experienced machine learning in one form or another. If you have a credit score, or received a fraud warning from your credit card company about a recent transaction, or saw a web advertisement related to a recent search or website that you visited, these are all examples of how machine learning is affecting our daily lives. Machine learning is changing the world, but those changes are not uniform. For every company that is successfully deploying machine learning and achieving a positive return for their efforts, there are at least two who have yet to see a return. This is actually a result from an MIT Sloan management survey, with 65% of those deploying AI yet to see a return on that investment. 46% of companies in that same survey see a strategic opportunity in AI, but more interestingly, another 45% see both an opportunity as well as a risk, and that is a risk that they will be left behind. Before we continue, let's pause for a minute to talk about terminology. I've already used the words AI, machine learning, and data science. This is a hot topic in the industry and in the media, and some of those terms are thrown around rather loosely. Artificial intelligence goes back decades to the idea of imparting machines with human-like behavior and intelligence that is often depicted in science fiction, but that level of AI doesn't yet exist. Today, AI is more narrowly focused to programs that can sense, act, and adapt in the real world as good or better than, in some cases, than humans. But this narrow definition of artificial intelligence also encompasses all of the techniques and technologies developed over the decades, like machine learning and deep learning. Machine learning is a subset of AI that uses mathematical algorithms that learn from data and can produce results without explicitly being programmed. This includes things like prediction and classification algorithms. Deep learning is a subset of machine learning focused on using neural networks to learn from vast amounts of data. And data science is a discipline for extracting knowledge and insights from data that encompasses all of these methods. However, it's not so easy. The value of machine learning is clear as a means to extract more value from data and transform the way that organizations do business. With all the potential in machine learning, what is getting in the way of realizing more value? From our experience in working with customers on their digital transformations and adoptions of machine learning, we see that there are several key challenges. The first is access to data. Machine learning can't happen without data. With data spread across different data management systems and in different data centers, often controlled by different business units, it can be a challenge to find data and make it available to your data practitioners. Second is a complex lifecycle, which is required to build machine learning models. That lifecycle is often complex and time-consuming, and it requires access to the right tools, infrastructure, along with coordination between multiple contributors of different roles. The third is operationalizing machine learning. To achieve the ROI of machine learning, it is not enough to just build machine learning models. Those models must also be put into operation, monitored, evaluated over time. As circumstances change, they need to be updated as well. At Oracle, we recognize that machine learning comes with many challenges, but we're providing solutions to make machine learning easier for you with more simplicity, more time, and more results, so you can get more out of your machine learning capabilities. This is how we describe our approach to AI technology across Oracle's product stack. Ready to go refers to applications that have data science-driven features, but they don't necessarily require data science expertise from the end user. End users can benefit from the machine learning that is behind the features without really knowing that they're using machine learning at all. These machine learning features have already been added to many of our applications, and we continue to add more. Our adaptive intelligent apps are leading the way in this space by automating grunt work, handling exceptions, and changing the user experience to adapt to user behavior. Ready to work refers to our platform services with machine learning driven features. These are platforms services that serve your IT professionals, data architects, and analysts and they're the building blocks of enterprise solutions. The prime example being the Oracle Autonomous Database, which is self-driving, self-securing, self-repairing. Another example is Oracle Analytics Cloud. With its explain feature, it automatically generates a written description of your visualization, for example. Ready to build refers to our machine learning solutions. These solutions serve your data scientists, your citizen data scientists, and others that work with data. It's the tools that we provide to build and deploy machine learning models, but it's also the supporting services like data management, business analytics, and infrastructure that go along with that. If you can get machine learning functionality in applications and platform services, why would you need to build your own? For the same reason that organizations want to write their own custom applications. Everyone has their own unique business problems, and everyone has their own data, and organizations have learned that their data is one of their most valuable assets. So to derive the most value from that data, they need to apply the techniques of machine learning to their data for their unique needs. Building machine learning models has always relied on various machine learning tools, platforms, and other open source libraries, and those tools continue to evolve rapidly. But building machine learning solutions always starts with data and is driven by a business problem. You need data management systems to store and secure your data. You also need infrastructure to run those machine learning tools. And the results of that work need to be consumed by your users or by other systems to actually get that value. You may know Oracle from data management, but we have had capabilities for machine learning solutions for several decades. When you look at what Oracle is doing around the tools to build machine learning models, we have 3 different solutions because different parts of the organization will have various needs that can be met with different platforms. This provides flexibility because you can use any or all of these solutions. First, we provide capabilities to build and execute machine learning in our data management platforms. We've been doing this for a long time. It's actually been in market for 19 years, over 19 years now, and we continue to invest heavily in this approach. So you can think of this as bringing the algorithms to the data. This means that you don't need to move your data out of the database, but you can train a model within the database using the implemented, embedded, scalable, high-performance algorithms of Oracle database. Secondly, we acquired datascience.com in 2018, where I was an employee, and we've brought the datascience.com platform to Oracle Cloud infrastructure to enable the professional data scientists on Oracle Cloud. Third, if you have a specific tool or platform that you would like to run in the cloud, you can bring it onto Oracle Cloud infrastructure and take advantage of Oracle Cloud's high performance and low cost in the Gen 2 infrastructure. For the rest of this presentation, I'm going to dive into a lot more detail on the middle one, OCI Data Science, which I am currently working on. OCI Data Science is a collaborative enterprise-grade platform for teams of data scientists to build, train, and manage machine learning models on Oracle Cloud. This platform is built for the modern expert data scientist professional who wants to control and customize each step of their data science workflow by coding in Python and using open source libraries. We enable data scientists to quickly get started working with all of their favorite tools in a managed and collaborative environment, which ultimately is going to boost their productivity and get them going faster. The service is built on the foundation of Oracle Cloud and also Oracle's integrated data management offering. As we charge only for the underlying compute resources, it's an extremely cost-effective offering. At the end of the day, OCI Data Science helps data scientists to create the best model, put it into production, and make sure it continues to perform over time. There are a number of challenges that we see in the market around Oracle Cloud Data Science on both the technical as well as on the business side. Starting with the business challenges, we see enterprises today struggling with budget restrictions and limited resources. The job market today for data scientists is particularly hot, and data science talent is in general in high demand. It's difficult and expensive to recruit and train data science talent in most any organization. We see businesses today struggling to maximize the return on their investment for their data science efforts, and organizations are looking to level up and amplify the output that their data scientists can make that they do have on staff. Next, organizations need to really be thinking about how to mitigate risk around important models in production. Since models learn on historical data, As soon as you put a model into production, it's going to immediately start to lose predictive power since the business climate around it is going to be changing over time. Organizations really need to be thinking about having plans and systems in place to retrain and redeploy models to ensure that models maintain an acceptable level of accuracy over time. However, quite often, the maintenance of production models relies on institutional knowledge within an organization. And unfortunately, data scientists typically do not have a reliable way to reproduce and audit the work of their teammates. And if a key resource leaves the company or is out on vacation or out sick, it can be challenging, if not impossible, for a data science team to step in and update a model in production without that legacy knowledge that that key stakeholder may have. Lastly, data science as we know it today is still a relatively new discipline. Unlike software engineering, for example, there are not yet industry-wide standards and best practices. Oftentimes we see organizations that are near the start of their data science initiatives and are looking for the right ways to add structure. A data science platform can be a central piece to create a data science center of excellence within an organization. On the technical challenges side, first of all, there are challenges around operationalizing and maintaining machine learning models. In some cases, data scientists are responsible for operationalizing their models, and they need an easy way to do this that does not require a lot of heavy lifting, provisioning and configuring infrastructure, installing software, and then maintaining it over time. In other cases, there is a handoff between data scientists who develop the models and engineers to determine how to operationalize and productionize models. This handoff is oftentimes quite lengthy and requires a lot of back and forth. It may even involve rewriting the model itself. When there are updates, this repeats itself. Either way, it's costly to an organization. Second challenge, access to latest technologies to scale up data science projects. In today's enterprises, data volumes are growing ever larger. Data scientists can train better and more complex models on larger sets of data, but this requires processing power. In some cases, CPUs on a single virtual machine, even if it is large, won't cut it. In order to train these models in a reasonable amount of time, data scientists need to use GPU machines or even distribute their workloads over a cluster of computing nodes. These kinds of systems are difficult and expensive to develop on premises. Naturally, businesses will want to take advantage of GPU hardware and other specialized technology in the cloud to minimize procurement and development costs. Next, working in silos in their organization, a very human problem. Data scientists often work in silos, oftentimes in an environment they set up on their own laptops. When a data scientist shares a model with a colleague, it can be impossible to get it to run in a different environment. Data scientists are also doing a lot of repetitive and duplicative tasks. If data scientists could share assets, data sets, code files, models, etc., they could eliminate a lot of redundant work. Lastly, data scientists are spending too much time on DevOps work. Data scientists are experts in analyzing data, experts in data science methodology, experts in their business climate. They oftentimes do not have the expertise or the appetite for DevOps type work, provisioning and configuring hardware, installing software, troubleshooting, maintaining environments over time. They need a solution that handles this for them. So how does Oracle Cloud Infrastructure Data Science address these challenges? With features for collaboration and governance around data science, the service boosts productivity and therefore ROI for data science teams. Shared projects enable teams to organize and document their work. The model catalog is a way for data scientists to store their models in a central place where their colleagues can always access and reproduce them. It also tracks where models came from and how they were created for auditing purposes. Version control enables teams to work together on code files. And finally, the service is integrated with OCI's security capabilities, which enable fine-grained access control for data science assets. Next, OCI Data Science enables data scientists to spend less time on drudgery and repetitive tasks and ultimately get more done. We offer automated machine learning, or AutoML, which offers automated feature selection, automated algorithm selection, and automated hyperparameter tuning. AutoML enables data scientists to quickly get a decently accurate model candidate without doing each step from scratch. We also offer model evaluation, which helps data scientists to understand how accurate their model candidate is. and model explanation, which helps data scientists to understand the behavior of their models and what features of it are driving predictions. This is especially useful to detect bias in a model, for example. Next, data scientists want to use open source tools. There has been great innovation in the Python ecosystem of open source machine learning libraries, and we offer all of that built in. Tools that data scientists love, like JupyterLab, TensorFlow, Keras, Scikit-learn, Pandas, NumPy, and many more, are already installed in the service, so data scientists don't need to spend time getting started. In addition, data scientists can install additional Python libraries that they like to use if we do not happen to offer a specific tool. Next, OCI Data Science is a managed service. Neither data scientists nor their IT counterparts will need to manage infrastructure. All of the infrastructure is managed by Oracle. Data scientists can simply access the amount of resources they need for their workload on demand. In our service, you will only pay for the underlying compute and storage infrastructure used, with no premium for all of the great premium features. Simply access what you need when you need it and only pay for what you use. Coupled with the great and fast performance of Oracle Cloud, this is an extremely cost-effective way to do data science. Lastly, you can access data from nearly any data source. OCI Data Science is data source agnostic. Data can be stored on Oracle Cloud, for example, in the Autonomous Database or in object storage, or it could be stored on premises or in another cloud. OCI Data Science is also data format agnostic, so you can bring structured or unstructured data, tabular data, audio, image, video, text, etc. to the service for modeling purposes. You can try out the data science service today on Oracle Cloud. When you sign up for a free trial, you can get $300 of free credits for 30 days to try us out. That concludes the presentation portion of this session. I will now show you a brief demonstration of how you can use the service to create a model to predict employee attrition. Here I am in the Oracle Cloud Console. I'm using the left side navigation to navigate to the data science service, where I am greeted by all of the projects that I have in my organization. I've opened up my project that I've created called Employee Attrition, where I'm going to create a model to determine why an employee might leave a company. In this project, I am creating a notebook session. Notebook sessions are the compute and storage and networking configured that I need to be able to run my JupyterLab session, which will enable me to write and execute Python code. So I've created that notebook session, I've opened it up, and I'm greeted by the JupyterLab interface. This is an open source tool that's very popular with data scientists in the Python ecosystem to create and build models. So in my first cell, I am able to write some Python code. This is some import statements to import some packages that I'll use in the rest of the notebook. Now I have run the notebook previously, so I'm walking you through, I'm showing you some of the visualizations that our advanced accelerated data science library helps you create. So with one line of code, this show in notebook code, I have created some data profiles very quickly against my data set. So I'm seeing summary statistics about my data set. I'm seeing feature level distributions and visualizations of what each feature of my data set looks like. This is helping me to understand what the overall look and feel is of my data set and help me decide how I'm going to approach modeling this data set. In this visualization, I see a co-correlation map of all the different features and how they correlate with each other. I can start to understand what features I might be able to drop from my data set to be able to move on with my modeling. I've applied some automated data transformations to this data set, and then I'm using the AutoML portion of the Accelerated Data Science Library to do some automated feature selection, automated algorithm selection to build my model, and some automated hyperparameter tuning to tune my model and get a decent model candidate. Then I'm using the evaluation portion of the Accelerated Data Science Library to generate a bunch of useful statistics and visualizations that help me understand how accurate my model is and how it might perform in production. I'm using the explanation portion of the Accelerated Data Science Library to create a bunch of, again, visualizations and metrics that I can use to understand how my model will behave. I've then saved the model to the model catalog, which is a portion of my project. I've clicked into my model and I can now use this model, load it into other notebook sessions for testing and evaluation and comparison purposes, or I can download it and deploy it as a function on Oracle Functions for real-time deployment. Thank you for joining this session today. I hope that you saw how Oracle Cloud Infrastructure Data Science can help make your data scientists more productive to use open source tools on powerful cloud infrastructure. As you know, you can sign up today using our free trial program on Oracle Cloud. And don't forget that we have links to helpful resources. We'll be doing a Q&A and appreciate your feedback in that survey. Thanks.